Remember, the content on our show is for information only.
It is not intended to provide medical or other professional advice. Okay. Hello, and welcome to Placebo, the podcast where each week we take turns teaching each other something new about healthcare or medicine. I'm Kaylin Richards, and this is my brother.
And I'm Logan Richards.
Hello, brother. And today I could not decide what to research, and I started to panic, and then I decided to do something different that we haven't done before.
Well, that's usually what the goal is.
Of panic or...
Something different.
Okay. I decided we would do a kind of update or look back at some previous topics we've done and some new information that has come out on those.
Okay, an update episode.
Episode update. Yes. A lot of shows do this maybe one time per year, but maybe we'll do it more often if we can't think of other topics to do.
We'll do it whenever we're not quite ready for another idea.
So the first update I want to talk about is from our episode number 2, which was the one about the gut microbiome.
Okay.
Okay, that came out in May. It was many months ago.
My goodness.
May of this year.
Pretty crazy.
Yeah. Can you even remember it?
No.
No. Oh, you don't remember the episode?
No.
Okay. So I was going to ask you, what do you remember from the episode?
I remember the bacteria are controlling our lives.
Sort of.
Yeah.
Remembering these were all mouse studies for the most part, and we know now more about mouse studies and how they have questionable application to people. Mm-hmm. But yeah, it was talking about maybe how the microbiome, the bacteria that is in your intestines affects kind of your thinking, if you have how you respond to different things, if you have depression or anxiety, things like that. So now there has been some new research coming out.
Oh my goodness. Since May?
Since May, new research. So one thing that we talked about in the episode was called clean mice. Do you remember what that meant?
Yes, they had no bacteria.
Yeah. So most of the time you have various colonies of bacteria in your intestines, and mice would too, and they breed these mice in a specially controlled environment with no bacteria available to get into them.
Right.
So they're totally clean.
They're free from mind control.
They're free from, I guess, sure. So those are going to come back into play in a minute. So we're going to go on to something else, and then these clean mice are going to pop back in.
Okay.
Okay. There are a few new studies that have come out recently, and they're looking at how the gut microbiome affects malnourishment in children, which is kind of a sad story. So typically, in a typical person, any person, you start out when you're a baby, you have kind of what they would call an immature microbiome because you're new. You don't have all the bacteria haven't had a chance to establish themselves. And plus, you're having kind of a restricted diet when you're a baby.
Yes.
So as you kind of transition to the variety of foods that, you eat throughout the rest of your life, that kind of changes and becomes the more mature microbiome.
Okay.
When the study looked at malnourished children, and they looked at them in Bangladesh and Malawi, so kind of different parts of the world where the diet is different, and you would think maybe the type of bacteria could be different.
Certainly.
They found that the expected change in bacterial communities didn't happen in the malnourished children. So the kids that were the most malnourished kept their immature kind of microbiome as they grew up.
Oh, interesting.
And the kids that were less so, maybe had better health, their microbiome switched over. So they decided, usually you go from mice to people, maybe when you're studying trajectory. But in this one, they were looking at the kids, and then they decided to take it back to mice. And this is where the clean mice come in. Okay. So they took the clean mice, and they fed them the diet typical of the Malawian children, which seems a little weird to me, because just because they're feeding it to kids doesn't mean that it's a good or bad diet for mice. Like, I don't know.
They just wanted to control that variable, I guess.
I guess. Okay. So they
what did the Malawian children eat?
Didn't say. I don't know.
Okay.
So anyways, they gave the mice this diet, and then they either gave them, because they didn't have any gut bacteria, so then they either gave them the type of bacteria that are found in the immature children, the immature population of bacteria in the children, or the mature microbiome bacteria, whatever.
Okay, so they injected those bacteria into the mice system.
Yes, and then they are both both groups of mice were fed this Malawian
Same diet.
children's diet.
Okay.
Yes. So the mice that were given the normal microbiome, the mature microbiome, developed more muscle mass and stronger bones than did the mice with the immature microbiome. Even though they were eating the same diet, the same amount, they weren't restricted in,
and they were exercising the same amount, I would assume.
I guess. I don't know how you can exactly decide how much a mouse will exercise unless you put it in a wheel and make it run or something.
I would imagine that would have to do with the amount of muscle mass and bone density they developed, though.
Well, they didn't comment on the type of exercise that the mice received in this article.
If they're just laying down, I wouldn't expect much muscle mass.
Laying down mice. Well, they probably moved around like mice normally do.
But what if one group was exercising way more than the other?
I can't answer all these questions in my brief update episode. I just don't know.
Okay.
And a possible reason that they discussed, not related to exercise, was hormones. So we did talk about this a little bit in our episode, that they thought that maybe so we're talking about how, like, for example, when the microbiome might make you feel depressed or whatever, how exactly would that affect your whole body and stuff like that. And one of the possible explanations for that was also hormones, like it gets into the bloodstream and circulates around the body.
Okay.
And I should say what gets into the bloodstream is like byproducts from the bacteria processing what you're eating.
Right, okay.
Okay, and there are different byproducts based on the different types of bacteria. So they thought maybe it is hormonal in this case, and that bacteria in the more mature microbiome group have more helpful byproducts that go into the hormonal system and help build muscle better and stuff like that. Okay. So the question is how to solve this. Like, why are some of these kids that are in these countries where they are malnourished, why are they, malnourishment has to do with the country, why are some of these kids that are malnourished proceeding, some of them are going to the more mature microbiome and some are not? And so why is that?
I don't know.
Okay.
Is it exercise?
No. Well, that's not what they said. So what they thought was maybe it's related to breastfeeding and like starting from a little baby.
Oh, well, that's a controversial topic, isn't it?
Breastfeeding, I think people agree that breastfeeding is usually best if you can.
Oh, well, I don't know anything about it.
Okay. Breast milk provides a particular type of sugar to the baby that's in the milk, and with a long name, which I didn't write down because it was very lengthy. But it is not something that can be processed by the baby. It's not something that the baby's GI system can process, but it is processable by bacteria.
Okay.
So the theory is that type of sugar is meant to encourage the growth of the particular type of bacteria that produces these byproducts that humans benefit from more so. So another reason why breastfeeding maybe is helpful and a good thing to do if possible. So the theory was that for mothers that were maybe malnourished themselves and were unable to breastfeed or breastfeed sufficiently, or the baby was on formula for whatever reason in these countries, I don't know, that maybe that was part of the reason why some were able to progress and grow their microbiome as it should do and some were not.
Huh.
I don't know. So I hope I explained that semi-clearly.
Yeah.
Okay.
So what's our update? Our update is that
I guess there's just continuing research into how the microbiome affects us at all stages of life. I think we didn't really talk at all about babies and children in our episode.
Sure.
And even starting when you're a new baby and you're being breastfed, that really kind of jumpstarts how your microbiome develops.
Very interesting.
So, and maybe because not every mother can breastfeed for whatever reason, maybe looking at how baby formulas are made, and maybe I don't know if they include this particular sugar or not. Maybe that's something to consider.
That is very interesting.
So, moving on to a next topic.
Okay. I'm ready.
You're ready? Okay. So, I want to talk about longevity. So, our original episode about this came out in June of this year, and it was our episode number 7. We talked a lot about Aubrey de Grey in that episode. Do you remember him?
He was a researcher.
Okay. And what is his research focused on?
Longevity.
Okay. Yes. And any other thoughts about that?
Beyond that, I don't remember the specifics.
Okay.
What am I supposed to remember?
Well,
He's the longevity guy.
Yeah. And so
he had pillars of longevity.
he had some like main things that he's a research group that he is leading, and he has some 7, I think, main points that he's trying to study about pillars, sure.
Yeah.
About longevity. And I think his biggest takeaway was that he considers aging curable, like it is a disease that can be cured, not that we need to cure other diseases, but that cure the whole picture of aging, and that therefore there's no necessarily lifespan or limit to the lifespan for humans.
Right.
Okay,
so you're going to talk about all the news articles? So
there's news articles that came out, I think, this week. Mm-hmm. And I saw one in Scientific American, but it was actually talking about a research paper that was published in the journal Nature.
Okay.
And
Nature always has the best stuff.
But the article that it was in Scientific American was titled, Humans May Have Already Reached Their Maximum Lifespan. And I thought, oh, well, that sounds like the opposite of what Aubrey de Grey is saying anyways.
Yeah.
Basically, this article is looking at demographic and epidemiological data, and that is in international databases, and they particularly focused on data from, I think, France, Japan, and the US and the UK, because those are countries with the largest numbers of people over 100, which I think is called, let's see if I can pronounce it right.
Centenarians.
Supracentenarians, because centenarians would just be up to 100, and super would be more than 100.
Ah, the supercentenarians.
Yeah.
Of course.
So the study basically found that lifespan increased rapidly, average lifespan increased rapidly throughout the 20th century, especially from 1930s onward. Do you know why 1930s?
Oh, well, that was after the Great Depression.
Think about healthcare and think about an episode that you did quite recently.
That was when penicillin was
that was when
discovered.
Antibiotics came into widespread use. Yeah.
Okay.
Yeah. So, starting especially then, there was a huge increase up until about the 1990s, and then it kind of starts tapering off. And then looking at how old the oldest people are, also tapering off around then.
Why does it taper off in the 90s?
Well, they think that's what they're suggesting, is that maybe it's kind of come up to the natural limit for health for humans.
Or maybe our antibiotics aren't working very well anymore.
No. So basically they said that maybe the natural limit of human lifespan is around 115 years or so based on that study.
Right.
But in the Scientific American article, then they kind of comment on that medicine is not included in this study, though. They're just looking at epidemiological results, not where medicine might go in the future or things like that.
Yeah.
So they didn't really consider gene suppression therapy, or there have been studies that show food restriction, for example, really increases the lifespan in other species, not humans necessarily, but or studies where they can extend the telomeres on the chromosomes, right, and make them longer so you don't age as rapidly. So it didn't really consider any of these possible things that could come into play in the future.
That is interesting. I think a lot of the larger news sources didn't do a good job of explaining that. Because I read several, more mainstream news articles that were basically just the researchers did their research and now we can't live past 115. Too bad.
So, not to say that Aubrey de Grey might be a lot overstating the simplicity of the case, and when he's saying there's no limit.
He seems like an optimist anyways, in that regard.
And it's not bad to be an optimist, but I don't know how realistic his statements are or not. But I also don't think...
He likes to challenge himself.
Yes, good. But I also don't think that 115 is necessarily the limit. I think 115 is maybe the limit with our current society, but science is ongoing as our podcasters point. Yeah.
That's kind of weird, though, that they say medicine's not included, but then they
but their graph
ascribe
clearly
medicine to...
Well, their graph clearly shows 1930, whoop, suddenly
So doesn't that mean medicine was included for part of...
Yes and no. I guess they just didn't consider the causes. They just considered what the statistics were showing, and then it shows that it tapers off.
Because if they had done the same research before 1920s, they would have said we can only live till 52 or whatever.
Great point, right? It's all from the perspective, because that would have shown maybe a very slow increase over time, maybe some drops around like the Black Death and stuff. But
yeah, confusing. I wonder if the researchers did any interviews
they
try
did
and explain their stuff more.
Let's see, I have the article up so I can kind of read some quotes if you want. So one author says, I'm not saying that drugs or tissue engineering couldn't be very beneficial to increase our average lifespan, but will they really enable us to break through the ceiling of 115? I find that highly unlikely. Lifespan is controlled by too many genes. You could maybe plug up one of the holes, but there are still another 10,000 holes springing up. So that's one of the authors to that study.
10,000 seems reasonable.
He's one of the authors of the study. Jan Vijig. I'm not sure if I'm pronouncing his name right.
Oh, of course.
Vijg.
Look to our references if you're interested in the spelling of that
I'm
person's
sorry, Jan,
name.
if I'm not saying it right. And then I guess, of course, they conclude their article with a quote from Aubrey de Grey.
Oh, really?
Always the go-to source for any interesting quotes on longevity.
Right.
So his answer is to this point of Vijig's point that there are too many factors. You could never control for all of them. You could never solve for all of them. So he really feels like even as medicine advances, probably that's about where the lifespan will stay.
Did Aubrey de Grey make a comment after this article came out?
It's inside of this article, so they must have interviewed him for it.
Oh, okay.
So he says, I think they probably asked him about this exact point about there are too many holes, too many things to address.
Uh-huh.
And he thinks he's got his 7 points or whatever it was.
There's only 7, not 10,000.
Depends on how you look at it and what you count as a separate thing, I guess.
Yeah.
So he says, quote, unlike a dam, the pressure on the so far unplugged leaks actually diminishes as one plugs more and more of them, he says. The result in this paper is absolutely correct, but it says nothing about the potential of future medicine, only the performance of today's and yesterday's medicine.
Yeah, that's what I would think,
Which I do agree. I mean, I don't know how much I agree with him overall, but I do agree that it is not looking at the potential for the future.
We don't know anything about the first part of his statement. Saying
right. I don't know why he believes that. Yeah.
But it seems to me that if you're looking at epidemiological data and you only have data that's retrospective,
that's all you can know about is maybe the current and the past. You don't know.
Yeah, it seems weird to make that prediction when they clearly saw that medicine was very influential in the length of life at certain points that we know.
I guess what they're saying is this is the trend line that we have. We can see that it's plateaued for 20-ish years. So
there also hasn't been any major medical discoveries going from no antibiotics to all of a sudden having
nothing
antibiotics.
Comparable to that sudden discovery, right?
No.
Yeah. So I don't think I agree with Jan Vijay about saying that 115 is probably it. Probably we're not going to increase beyond that. I think there's a lot left to be discovered, and we can't really make that point.
Yeah. Who knows?
From my perspective. I want to move on to one last update.
Okay.
This one is our hand washing episode.
Ah.
Okay.
Did I do that? Or did you?
You did that, yeah.
Okay.
So it was episode number 14. Came out in August, a couple months ago.
Okay.
And it mainly was focused on hand hygiene, hand washing with healthcare workers or in the healthcare environment.
Sure.
Is what I'm remembering.
Yeah,
Does that sound about right?
Sounds about right.
I remember you talked a lot about how the effect of observers changed how people did their hand washing and stuff like that.
Yeah.
So this is not related exactly to that, but it is related to hand washing.
Okay.
Kind of a different facet. So I don't believe we
was this antibacterial soaps?
Yeah.
Okay.
I don't think we discussed any of that in the episode. And
we did not. No, there was no mention of that.
No, because a couple of weeks after that episode was published, the FDA came out with their statement, which was announcing that they were banning the sale of many types of antibacterial products. I think about 40 different chemicals that are currently being used in antibacterial products are now going to be banned. However, this is just in to the public, you and I going to the grocery store or whatever and buying soap.
Okay, yeah.
This is not going to be to the healthcare environment. So in hospitals, probably the soaps are still going to be antibacterial. and the hand sanitizers and stuff will have
obviously
these chemicals. Well, I don't necessarily think it should be, obviously, because the reason that the FDA is...
Well, I was saying the Purell, because that's like, it's...
Oh, not to buzz market, yes.
Hand sanitizer has to be antibacterial, otherwise what is it? Just a gel.
It's just a gel. But I think maybe we'll see what happens in the future. But what the FDA said is that they are banning a lot of these products. Two of the most common ones are triclosan, which is mostly in liquid soap. I know it's in Purell, buzz market, because I've seen it on the label.
Okay.
And trichlocarbon, which is in hard soaps.
Oh, okay. No one uses hard soaps anymore.
Well, some people do, I guess. Those are the most common of the chemicals that are being banned.
Okay.
So I think those are pretty much like all of the antibacterial products.
Yeah.
You would see that in. Oh, it says nearly half of the soaps on the market contain at least one of these newly banned chemicals. So it's going to be a lot of changes coming up.
Because not all soaps are antibacterial. So are they saying only the antibacterial, half of the antibacterial soaps?
These are chemicals that make, soaps on the market, it said.
So half of soaps on the market are antibacterial?
Yeah, nearly half.
Oh.
So the reason that they're banning them is because the industry, the soap hand sanitizer industry, has been unable to show that they are safe or that they are beneficial.
Oh,
so
interesting.
In this usage anyways. They did, for example, there was a toothpaste, I think it was Colgate Total, uses triclosan in it. Mm-hmm. And the FDA said they were able to provide enough data that it was not harmful and that it was beneficial in that use. So they're not having to change their formula.
So as long as you can prove it, then the FDA is allowing it?
As long as you can show sufficient research. Of course, I didn't find any of this direct research. I'm suspecting maybe a lot of it is proprietary and maybe submitted directly to the FDA and not public.
It's really hard to find stuff like that sometimes.
Mm-hmm. So, or maybe I wasn't using the correct search terms.
But research articles never mention brand names.
Yeah.
And like if that's the only information you have, it's really hard to find.
Yeah. So, I unfortunately don't have the direct study results that we can make our own conclusions from.
Okay.
But I think they have a year to change their formulas, and I think next year they have to start producing the soaps without. There are also a few other chemicals that are still under consideration.
Yeah, I was going to say, are we just going to see a formula change and all the soaps will still be antibacterial? They just won't have the chemicals that are banned now? Just have different ones?
I'm not clear on that. Because like straight up alcohol is antibacterial, right? Because it destroys the cell walls of the bacteria.
Okay.
That's why if you have nothing else, pour some alcohol on a cut or something, right?
That's why usually they sanitize your arm for an injection with a little alcohol swab.
Mm-hmm. It says the agency FDA. Oh, and for our non-American listeners, maybe we should say what that is. Oh, I just thought.
It's the Food and Drug Administration.
Yeah, it's a governmental agency that regulates food and drug products.
And drugs.
Yeah. Okay, so it says they are also studying the safety and efficacy of hand sanitizers and wipes beyond soaps, and have asked the companies for data on 3 active ingredients, 2 of which are alcohol, ethyl alcohol, isopropyl alcohol, and benzalkonium chloride. And it hasn't decided on those yet. It still is waiting for more data.
Okay. What prompted the FDA to look into this data and make this decision? Is it because of antibiotic resistance? Is it because they think there's a better option for soaps and these are not meeting the... So
antibiotic resistance is one of the components. Okay. And that's why I'm wondering if they're just recommending... I know that in general, the recommendation is if you don't work in a healthcare environment, you don't need antibacterial products, and you should just use regular soap and water. And using antibacterial products when you don't need them is something that leads to more drug-resistant bacteria.
Well, that's a pretty general thought about antibiotics too, right?
Yes.
There's no need to take those if you don't need them.
There is also concerns about these antimicrobial chemicals and that they can affect hormones in children particularly, which is an important time to have your hormones go right, like we talked about in the
just
part
10
about...
minutes ago.
Yeah. And, as you're a child and you're maybe developing into an adult, you need to have the correct hormones then too, otherwise things can go wrong. The problem with a lot of these antimicrobial chemicals is that they stay around in the environment too. Like there's been studies that find them in people's urine, in their blood, in like the water supply, in dust around you. So it's once they are in the environment, they stay around and they don't break down for a long time. And if there's concerns about how they affect like developing children and your hormone levels and stuff, and we don't know exactly what they do, I think that if there's no clear benefit,
it does seem like an issue.
It does seem like an issue. So, which is why the FDA has decided to get rid of them in further going forward after the next year.
Okay, so what was the ruling that they made? You can't have these lists of products after a certain amount of time, or what?
So the products can remain. The products have to change their formula.
These list of ingredients.
So they can't use any of these ingredients.
Okay.
Yeah. So they first, in 2013, they kind of let the companies know that they were considering making this decision.
Oh.
So they've had a few years.
Well, the government doesn't go very quickly. So
no.
Not surprising.
And they had that amount of time to provide information that showed that these chemicals did more harm than good, basically. No, more good than harm.
Good than harm.
And the FDA did not feel convinced with the data that they were providing.
Is 2 years enough time to do enough research for them? Maybe.
I don't know.
Who knows? Maybe they thought maybe they should have already had most of the research.
Yeah.
Well, anyways, very interesting.
So what makes me a little sad is, and not understanding maybe the whole effect of these chemicals, because like I said, I don't have the data available to me, is that it is still going to be used in healthcare environments, and it's something that I'm putting on my hands like 20 times a day, every day.
20 times, probably more.
Probably more. Like I Purell my...
50 to 100.
Yeah. I hand sanitize my hands, not to say a product, but like every time I go in and out of a room, which could be multiple times for each patient and maybe 8 patients, say, per day. Mm-hmm. So like...
Sometimes I just throw my hand out and grab some sanitizer just when I'm walking.
But then I do wash my hands sometimes because your hands will feel gross after a while.
Right.
And then I'm using soap, which probably has this products in it too. So at least you're washing it off, but then it goes into the water system.
Do you think soaps in hospitals are all antimicrobial, or...
Pretty sure.
I don't know anything about the soaps that are used.
Well, they don't say anything on them, but I would be really shocked if they weren't.
I guess it would make sense, right?
One more thing to throw out about these chemicals is that they were initially, the triclosan and trichlocarbon were initially used by surgeons to wash their hands before, like, surgeries. So they were meant to be like, this is the hardcore
by themselves.
stuff. Yeah. Huh. And then kind of they've exploded in use in the recent years, and they've been put into things like, well, the toothpaste that I mentioned before, and all the different, like, everyday soaps that people can buy and use at the store.
Toothpaste seems interesting because there's... Mm-hmm. I imagine you swallow at least a small percentage of toothpaste whenever you're brushing your teeth that's like in your mouth.
It's been found, or it's been put into laundry detergent because it's saying killing the bacteria in your clothes so your clothes smell good. And
right.
But do you really need to do that? It's been like built into fabrics. Like you can get shirts that are antimicrobial. Yeah, it's been put into
shoes, probably
baby pacifiers because your baby throws it on the ground. You don't want germs in your baby's mouth.
What about plastics? A lot of medical devices that are plastic usually say they're antimicrobial.
Yeah, so I guess we should wrap this one up, but I keep wondering.
Let's just peter out like we always do.
I keep, rambling on about it.
And that's it. That's the episode.
That's it. If you, listener, enjoyed the episode, you could share it with a friend or leave a review on iTunes to help other people find it. That would be very nice.
You can visit our website, placebopodcast.com, for show notes or to send us any suggestions or feedback.
You can also find us on Facebook, and you can like us there.
Thank you to James Aiken for our music.
And again, thank you to you all for listening. We'll be back with a new episode next week.
I've already decided what it's going to be.
Oh, good job. I need to plan a little farther in the future.
Okay, goodbye.
Goodbye.